Okay, so these are the success criteria for chapter 2 kinematics. Okay, you notice that there are a lot of success criteria in this chapter. So used to be that this chapter is pretty massive. Okay, so depending on how far we have covered, I will set the test according to that. Okay, but there's quite a lot of formulas for you all to apply. Okay, let's start. Okay, success criteria A, state what is meant by speed and velocity. Still remember my scalar and vector story before we end, right, the bar one story. So, speed is actually a scalar. Still remember scalar? Okay, if you all have the notes, you will have to annotate, write it down. So, scalar only has magnitude. How about velocity? Magnitude and direction. But essentially, to the layman who are not taking physics, they are about the same. But as physics students, we need to make a distinction between speed and velocity. Okay, for pure physics, it is mainly dealing with velocity. But for us, we mainly deal with speed. Okay, but you still need to know the concept of velocity. You still need to know in a certain direction. But luckily for us, the directions will either be one way or two ways. It will not be anyhow moving. Okay? But sometimes it will be circular. So this is the first definition that you need to memorize. Distance is defined as how far an object travels from a reference point. So from a reference point, whatever distance whatever length the object moves, it is known as distance. Okay, so take for example, you run 2.4 around the school, 2.4 km. In the end, you came back to your original place. How far did you run? 2.4. This is distance. You covered this distance. You cannot roll back and say, no, I make a wrong turn, I want to rewind. Cannot. You have traveled, all right? But displacement is different. It is defined, this is also a definition you need to memorize, is defined as a distance traveled in a certain direction. So taking our 2.4 again, okay, you make one round, it's 2.4, but you ended up at the same place. That means your displacement is 0. Right? Your displacement is 0. But the distance is 2.4. You get the idea? So distance, actually, you don't need direction. You have covered it, that's it. But displacement, you need to see where you start from and how far you are from there. So are we okay? So this is important. That means in the test, I may ask you, hey, what's the difference between scalar and vector? Give some example. Then you will say, oh, distance is scalar. For vector, an example is displacement. But what is the unit for distance? SI unit. So remember SI unit we covered in chapter 1. Distance, the SI unit is meters. Displacement, the SI unit is also meters. Same. Because one has direction, the other don't have. Okay, now speed is defined as the distance traveled per unit time. So this is a formula that you need to memorize. This is the definition that you need to memorize. Okay. So V equals to D over T. D is called distance, right? What is the unit for distance? SI unit. Meters, right? What's the SI unit for time? Seconds. And that will therefore make speed having a unit of meter per second. So basically, if we follow the formula And if we know their corresponding units, we will know the unit of speed or velocity. Simple. So this is definition that you need to memorize. And what is instantaneous speed? It is a speed that an object has at a particular instant. Okay, so this is instantaneous. That means the speed at that point in time. Any question? An example, okay, what is uniform speed? Is when the change in distance traveled by an object per unit time is the same. So that is uniform speed. That means the speed doesn't change. Okay. Then we go to this thing called velocity. It's defined as the rate of change of displacement. So you need to memorize this. Can you all see from the back? You need to be able to memorize this. And it happens to have the same formula. Why is that so? Because one actually don't need direction, which is our speed. The other one needs direction. So let's use our 2.4 km per 2.4 as an example. So now you run one round. Please follow this story. One round is 2.4 km. What is the distance traveled? Distance is 2.4 km, right? What is the displacement? Displacement is 0. Get it? Why 0? Because you went back to your starting point. But now the school very rich. Instead of making your run one round, the school super big. Now instead of running a loop, you all run one straight line. Okay, because our school expanded. So what is the distance traveled? 2.4 km, right? Because you are doing your NAPA or something, right? What is the displacement? Displacement is also 2.4 km. So when is distance and displacement different? When the direction is different. When the direction is different, right? You see, when I do one loop, okay, the distance and displacement are different. But if they are traveling in the same direction, the displacement and distance will be the same. Y'all get this part? Yes. Okay, okay. So now our school track change again. So the distance traveled, now instead of running full loop, our school track change again. The distance traveled is 2.4. How about the displacement? The displacement will be this. Where is your starting point? Our start point is here. Where's our end point? It's over here. What is the actual distance that you run? Very tiring, run. 2.4 km. But where is your displacement? This red color. Then the school changed the track again. Yes, that's the shortest distance. Still 2.4. You ran this way. Okay, you ran 2.4. But what is the displacement now? Displacement will be this. Get this? So, if the distance and displacement may be different, speed and velocity will also be different. Because what is speed and velocity? So you need to know the difference between scalar and vector, and these are some examples. Okay, then we come back to this formula. Velocity is defined as a rate of displacement. So your velocity formula is the same as distance. But instead of using distance, you have to use displacement. You have to use displacement. Okay. Okay, next success criteria, calculate average speed using distance traveled over time taken. So this is average speed. total distance over time taken. There's also average velocity, which is total displacement over total time taken. So again, there might be difference if their direction is not the same. Okay, if they are not traveling in one direction. Now, for average speed, you need to take note of the rest time as well. So that means your total time, you need to take into account any rest time. That means if I start from A to B, I want to go from point A to point B, and in between, I have any rest period. Let's say I rest over here. I need to take into account the timing as well to be included in my calculation for average speed. Okay, can we try B1 and B2? Okay, B1 answer is B. Okay. How many of you use 80 plus 40 divided by 2? So what's 80? So you get 60 km per hour, right? So this is not correct because this is just the highest speed, right? Higher speed. Okay, so I quote you an example. Let's say I have 35 students here. 34 of you got 80 marks for your WA1. Okay, and one sad person got got 40 marks. What's the average marks for the whole class? Can you just take 80 plus 40 divided by 2? You cannot, right? So this is the same. There may be points in time when I'm traveling 100 km, all the way is 80 km per hour. Then only when I see police for that 1 second, it dropped to 40. So that one cannot be the average speed. So what's the average speed formula? Total distance over total time. Get this? Can I? So can I go to B2? Okay, B2, what's the circumference? Circumference is 2 pi r. 2 times 3.14 times, what's the radius? 50, right? So it becomes 314 meters, right? Am I right? That's the circumference, But he ran how many rounds? 2 rounds. So what's the total distance? So it's 628. So, and he took 100 seconds. Therefore, his average speed must be 6.28 meter per second. Yes? How about his average velocity? He went back to the same place. He ran 2 rounds. In the end, if you didn't see him run, you just close your eyes after 100 seconds. He just appear in front of you, panting, sweating. You never run now, go run again. Right, but he did run. He ran 628 meters. But his displacement finally is 0. So that's the difference between scalar and vector. Something new. See what is meant by acceleration. Have you heard of acceleration? So if I ask you to accelerate, what does it mean? Go faster, yes? How about decelerate? Go slower, okay? So an object is accelerating when the velocity changes. Now, what is velocity? It is a vector diagram, a vector quantity. Vector means has magnitude and direction. And acceleration is defined as the rate of change of velocity. That means as long as your velocity changes, there will be acceleration. But velocity has 2 components. Component 1 is the size, big or small. Okay. Component 2 is direction. If I change the size, that means my velocity go from 40 to 50. Am I accelerating? in my velocity went from 40 to 50. Am I accelerating? Is there a change in velocity? Yes, so I'm accelerating. But if my velocity is 40, but I change direction, is there acceleration? I change direction, is there acceleration? Because what is the definition for acceleration? Rate of change of velocity. But velocity got two things, one is the size, one is direction. As long as one changes or both changes, there is acceleration. Because like what the definition says. So anyone wants to ask me about this? Acceleration is a vector quantity. Why vector? From magnitude, it has direction. SI unit is meter per second, meter per second square. You all know what is meter per second square? Later I show you, okay? Okay, for an object whose velocity decreases over time, it is undergoing deceleration or retardation. Sometimes you hear this word called retardation. Okay, please use it as it is. Don't go and y'all don't purposely like you want your friend to slow down, then you like, hey, retard, retard. Retard is a action of slowing down. Okay. Now, an object undergoes uniform. Uniform, sometimes we call it constant. Okay, these two words we use interchangeably. An object undergoes constant acceleration or uniform acceleration when the change in its velocity per unit time is the same. So you need to memorize this formula. What is A equals to V minus U over T? Read the legend. A is acceleration. Units is meter per second square. Later I'll teach you how to get the units. V is final velocity. U is initial. How do you remember this? Which comes first, U or V? In the alphabet, which one comes first, U or V? Then your A, B, C, D, E, F, G, S, T, U, V. So U comes first, right? So U will be the initial velocity. And because V comes after U, it is then the final. We always use the final minus the initial. Right? Just like some weight loss program that they show on TV, right? They show the before and then the after, right? So we take the final, subtract away the initial. T is our time. Now, if velocity is meter per second, time is seconds. How do we get meter per second square? Now, I will test you for math. Okay, V minus U, what is the final unit? What is the final unit for V minus U? You take 10 apples minus 5 apples. In the end, you get 5 apples. You take final velocity minus initial velocity. What's the final unit? Will be meter per second. Do you all get this? Why not? 10 apples minus 4 apples. How many? What is 10 apples minus 4 apples? 6 what? Oranges. 6 apples. Right? If they are the same time, you will get back the same unit. Don't keke. Don't act blur. Okay? What's the SI unit for time? Seconds. So this is your numerator. This is your denominator. Yes? Math. What thing? Why is you what? I'm asking about the units. apples minus 4 apples, what do you get? 10 apples minus 4 oranges, what do you get? You cannot. How can you take 10 apples minus 4 oranges? Right, so they must be of the same unit. That's why I get meter per second. Now, what is meter per second over second? You all learn math, right? Meter per second divided by seconds. You get meters. Alamak, come on. Do your math. You all forget about this. The divide, what must you do? Change it to times, right? Then your second become 1 over second, right? Then, this becomes what? Yeah, that's why A equals to B minus U over T, meter per second divided by second. In the end, the final unit is meter per second squared. Okay, guys, if you don't understand this math operation, it's okay. What is the SI unit for acceleration? Meter per second squared. Just memorize this. Okay. Can I get you to try D1 as homework? Okay, that's all. Okay, by right, C1 as homework. So next lesson we'll go through C1. By the way, can I check? Have you all done graph? Have you all done graph? Do you all like graph? You all like graph? Do you all know how to calculate gradient? Gradient, Okay, let me test you all. This one is meters. This one is seconds. How do we calculate gradient? Guys, stay with me. Last 1 minute. Please do this. I trust that you all have done your math properly. Gradient. Gradient. How do you find gradient? Rise over run. Or y2 minus y1 over x2 minus x1. Yes? Okay, still with me? So gradient is either rise over run or y2 minus y1 over x2 minus x1. Or better look here. So now, what is the unit for this rise? The unit is meters, right? Correct? Meters, What is the unit for this? I use another color. For this run. Seconds, Gradient is rise over run. So it's going to be meters over second. Y'all get this part? Can? Okay, thank you very much.